Welcome to EcoVapor's Tanks versus Towers webinar. Let's get started by introducing today's panel. Joining us from EcoVapor this morning is Chief Executive Officer Mike McMahon, Chief Technology Officer Hans Mueller, Chief Financial and Strategy Officer Emily Mills, and from Product Management, Jeff Wilson. Thank you very much, panelists, for being here today and sharing your expertise. This promises to be a great discussion. Mike, I'm going to hand it over to you.
Great, thanks, James, and good morning, everyone. Welcome to our webinar. We have over 100 people registered for this event, so it's great to see a high interest in EcoVapor and in the comparison of a vapor recovery tower versus full vapor capture scenario in an upstream facility. We have a wide range of roles in our audience today: upstream and midstream operators, engineering firms, other consultants, regulators, and then other good friends in the industry. So great to have you with us, and thanks for taking the time. At EcoVapor, we're experts in the recovery and treatment of gas streams, particularly the low pressure vapor generated in the tank battery of an upstream facility. It's challenging to manage this valuable stream and get it into the sales line, but we have expertise, and our designs are at work in over 110 installations in the field today. So our solution helps operators get results in many ways. First of all, achieving their company's ESG goals, also being compliant with their air permits. Our solution contributes to preventing venting on tanks by managing the tank pressure effectively. The presence of our solution in an air permit application, it streamlines the permitting process in many states. And also the results of our system improve the safety of the operation. A typical installation of an EcoVapor system shows a payback of just a few months, and we have several installations operating today that are on zero emission sites where there's flaring only in emergency. Now, VRTs have been used for many years and do provide a partial solution to 100% vapor recovery. EcoVapor performed field trials at several customer sites to measure the improvements that an EcoVapor system brings to facility performance versus a traditional VRT-based site. So I'll now turn it over to our CTO, Hans, to walk us through the trial plan.
Thanks, Mike. The purpose of the original concept of vapor capture directly from tank batteries was to simplify the facility in order essentially to avoid placing another vessel, a non-heated one in this case, between the primary separator and the tank batteries themselves. It's also true that simulation software such as HYSYS or ProMax can overestimate the VRT recovery efficiency by assuming perfect separation. We know that phase separation takes time. For example, when a pot of water reaches 212 degrees Fahrenheit, it does begin to boil, but it does take some time to convert all of that water into steam. And these simulation programs don't consider that transient aspect. So knowing this, EcoVapor was curious to measure the actual recovery efficiency, as well as any impact to oil production and gas sales volumes. And it turned out that so were a lot of operators. So EcoVapor partnered with a few clients to measure these results. Today, we'd like to dive into the results of a head-to-head test using a vapor recovery tower versus tank vapor recovery that look closely into the different operational setups. The trial plan was to essentially compare operation of vapor recovery using a VRT versus going directly off the tank battery itself. And in this process flow diagram that we're looking at right now, the base case is represented by scenario 1 in where the valve between the vapor recovery tower and the vapor recovery unit was open. This setup was operated for the first 11 weeks. The idea was to operate the facility with the VRU processing gas directly from the VRT and flare or combust any remaining tank vapors. In the second scenario in the process flow diagram, represented by where the valve between the VRT and the VRU is closed, the VRU pulls gas directly from the vapor space of the tank battery, and this actively controls tank pressures. Also, a small two-phase liquid scrubber and an oxygen treatment skid were installed. This second setup, the tank vapor recovery trial, ran for the subsequent 11 weeks. The VRT was bypassed, VRU was configured to capture the vapor directly from the tanks, and the oxygen removal equipment allowed the recovered stream to meet gas gathering spec. Also, the two-phase scrubber was harvesting any recoverable liquids. And in this setup, all gas and vapor flows to the gathering line, and any scrubbed liquids were sent to the oil tanks. In both trial setups, we were sure to closely measure a few different variables, including gas and oil production as measured at custody transfer, any oxygen that might have been sent to the gas gathering line, as well as the volume and value of the flash gas captured. We also were monitoring vapor recovery system uptime in both setups. We'll take a little closer look at that first scenario where we used the vapor recovery tower to facilitate recovery. Both of these trials were performed on a fairly typical facility configuration, 2 recently drilled horizontal wells in the Powder River Basin in this instance. VRT was used to assist with the vapor recovery efforts in the first phase of the trial. Again, this lasted for the first 11 weeks, and that established a baseline for recovered gas volumes and oil sales. The purpose of the VRT is to capture as much gas as possible upstream of the tank battery in order to avoid any potential for oxygen contamination by keeping things to a closed system. The low pressure operation of the VRT is important here too, and it's facilitated by gravity assisted oil feed to the tanks. Speaking about that low pressure of operation, it's typically about 2 to 3 PSI. So in that instance, a simulation program might suggest over 90% vapor capture efficiency. But remember what we were talking about earlier, that time component that's required to achieve that perfect separation. So in reality, well over 10% of that recoverable vapor is continuously flared or combusted with the VRT setup.
Yeah, Hans, what we see here with VRTs in our direct experience is that the process dynamics in a VRT cause some hydrocarbons to go into the vapor stage when without the VRT, those hydrocarbons would stay in the liquid form.
That's absolutely right. So in the second phase, the vapor recovery tower was taken out of service for that subsequent 11 weeks, and an oxygen removal skid and 2-phase separator were utilized to facilitate recovery in place of that VRT. This allowed the vapor to be collected and recovered directly from the tank battery. Also, the recovered stream from the tank batteries turned out to be super rich. It wasn't necessarily a surprise to us, but in this case, it was over 500 BTU more than the VRT gas that was recovered. Knowing how rich that stream was, we did want to try to give any recovered heavy NGLs another bite at the apple so that they could be sold as liquids in order to capture their full potential value. Concerns did exist about creating a propane loop. That's essentially where we'd be spending horsepower by moving propane in a circle between the tanks, the VRU and the scrubber, and over and over and over again. But actually, we did end up seeing immediately an oil production uplift, and that's measured at custody transfer, not just the Coriolis meter on the bottom of that 2-phase scrubber. So, in other words, by capturing more vapor, EcoVapor's client was also selling more oil. This result's been repeatable. It's been observed in over 100 02 installations. And just other things that we typically see with the 02 installation include high uptimes. In this trial, the oxygen removal equipment uptime was over 99%. And the VRU uptime in that second trial was 98%. Actually, the tank vapor capture setup helped VRU reliability by minimizing any effects from slugging. There was no potential for any liquid carryover, things like that. We also saw pretty typically that pressure drop through the oxygen removal system was well below 10 PSI. Gas temperature was within gas gathering specifications, and no downtime or shut-ins were attributable to any oxygen removal equipment during the trial.
Yeah, that's a great summary, Hans, and just wanted to make the observation that in this scenario, we don't add a VRU to the system, to the legacy system. We simply retask the VRU from the VRT to the tank battery.
That's absolutely right, Mike. Yeah, the VRU was present in both scenarios, and we just repurposed it.
Hey, Hans,
Yeah.
quick question. The truck shown here were truck vapors a part of this trial?
Jeff, good question. Oil hauler vapor was not captured in this particular trial, but that is something that EcoVapor regularly does help operators with. If we did capture the oil hauler vapor in the tank battery trial, that would have actually only augmented the performance of that setup. So just talking about this head-to-head trial, you know, it is obvious to probably everyone on this call that vapor recovery towers and ZerO2s serve similar purposes, and that is to try to reduce emissions by way of facilitating vapor capture. The difference does come down to performance, and it's highlighted by the ability to capture all vapor, including from oil tanks, produced water tanks, even oil haulers, and that's what helps to demonstrate that ZerO2 is the most economic solution to achieving this environmental goal. One other differentiator that's worth mentioning is that venting is virtually eliminated because the oil tank batteries and water tank batteries are actively controlled in their pressure. I'd like to provide a brief overview of the equipment itself. In all ZerO2s, regardless of size or capacity, it's a precious metal catalyst that facilitates the oxygen conversion reaction. In this instance, or I guess in all ZerO2s, the catalyst isn't consumed in the process. It's a true catalyst, and it does require regeneration about every 12 months, a lot of times longer than that, but that gives you a good idea of the periodicity of replacement. Currently, EcoVapor's two most popular models are the 300 MCF a day capacity unit and the 1.2 million, or 1200 MCF a day unit. Both skids, in terms of footprint, are about 4 foot by 4 foot. And it was one of the E300s, the smaller units, that was used in these trials to produce these results. They are totally deployable in parallel. We have had up to 6 of these units in parallel on a single facility. And in terms of operating pressure, we can get up to 410 PSI in terms of maximum allowable working pressure. These units are sensitive to H2S, but many sweetening options are available. We'd like to talk to you about them. And bottom line is that ZerO2s absolutely nuke oxygen. We can typically handle up to 50,000 parts per million oxygen. That's 5%. And that translates to about a quarter of the overall stream can be air, and you can sell it. Any more than that does cause the unit to stop, any more than that 50,000 parts per million, it can cause the unit to stop accepting gas while it cools down. Typically takes about 20 minutes or so for that to happen before it places itself back in service. Y'all probably don't need a reminder that it's 2020, but in 2020, remote monitoring is nothing new. That said, EcoVapor has tried to take this into new territory. Not only are EcoVapor's controllers perfectly compatible with existing SCADA systems via Modbus RTU if you prefer serial communication, or TCP/IP if Ethernet is your preference. Other protocols are available as well. But EcoVapor also facilitates monitoring and beyond on our own network, where every parameter of every piece of equipment is monitored and stored every 2 minutes, and that provides us with high resolution data trending. We can look back at any site, and so can our clients. We can look back at any site over any date range and see what was going on, and it only takes 3 clicks of a mouse. Tank pressure can be monitored and archived for record keeping. EcoVapor's network even facilitates remote control. We can see the touchscreen of the unit just on our phone or computer, just as if we were standing on site. We can even upload updates to operating code remotely. All of this allows EcoVapor to address any issues before they become problems. And typically, to be honest, we're helping operators address other facility issues like drifting pressure sensor calibrations, things like that. And that's what allows EcoVapor to achieve a 99.8% field upwide uptime, and that includes any planned maintenance. One last thing I'd like to mention is that EcoVapor's network was what was used to record and store all the data from this trial, and that's what we're looking at. With that, I'd like to introduce Emily Mills, EcoVapor Chief Financial and Strategy Officer. She'd like to walk us through the results of this head-to-head VRT versus tank vapor recovery trial. Thank you.
Yeah, thanks, Hans. So I'd like to walk you through the results of the trial that Hans just described for us. This is based on information provided by the operator over the same 77-day monitoring period. The operator observed overall a 3% increase in oil production and a 37% increase in tank vapor gas capture with the tank capture configuration compared to the VRT. This results in a 98% capture efficiency for the tank configuration versus the VRT. In addition, as Hans mentioned, the operator observed an increased BTU content of the gas captured in the tank configuration as a result of the vapors being pulled directly off the tanks. This translates to the operator capturing not only more gas, but more valuable gas. So overall, the operator reported that the present value of the full tank vapor capture scenario was approximately 2 times that of the partial capture scenario.
Thanks, Emily. If it's okay for me to jump in, I'd just like to take 1 second to point out that there are some rare instances where a 0-2 installation does provide less than positive economics, but in each of these instances, EcoVapor and the operator were well aware of the economics specific to that installation and chose to continue to move forward for external reasons. One example that's coming to mind is when EcoVapor's client chose to install tank vapor recovery equipment at an older well site that was located directly across the street from an elementary school. And although EcoVapor did convey to the operator that we didn't believe that there was enough recoverable vapor volume to offset the equipment and installation costs, the producer did feel that in this particular instance, there was enough of a reason to prevent continuous flaring on site. That doesn't happen very often. Those are the one-offs. Almost all EcoVapor installations are significantly above break even, with sold equipment paying back typically in a matter of months. And it's really not that hard to understand why when you're looking at these numbers. We can capture more richer gas and sell more oil by preventing that from going up in the air.
Right on. All right, could you walk us through the next slide?
Yeah, let me take a shot about gas going up in the air. So we measured estimated the impact on the emission profile of the site. We annualized the volumes based on the actual data over the basically, because it would be 14 weeks of the total trial. For one reason is typically emissions are reported in tons per year, so that we were trying to keep that consistent. We looked at 2 different kinds of emissions. On the left, you'll see regulated pollutants. And we made some assumptions to come up with these numbers. We used the actual volume data, but we assumed in this case a 90% VRU uptime and a 98% flare destruction efficiency to calculate these figures. And we used, in the footnote, the emission path factors from EPA's AP42 for the combustion products. You'll see with direct capturing from the tank, you capture more vapor, you have lower emissions from flaring. And on the right side, we address the greenhouse gases as well that are not currently regulated. They're reported in some regions. In this case, we use the hydrocarbon density factors from the EPA's greenhouse gas rule in the Code of Federal Regulations. Overall, you'll see about a 2/3 reduction in emissions, and it's really kind of simple. If you capture all the vapor instead of flaring it, then you don't have the emissions that are associated with that activity. I might add that as an interesting side that not every state regulation treats these 2 configurations, these 2 capture methods the same way. For example, in states like New Mexico and Wyoming and on federal lands, capturing from the tank with the VRU and the 0-2 with positive economics is considered process equipment, which allows the operator to really fall under a much more favorable permitting regime. Texas kind of functionally gets there under a different way. They use a capture credit program that if you're removing oxygen and have a VRU and pulling off the tanks, you get credits towards your potential to emit and can offset up to 100% of the potential emissions. Other states, like Colorado, they don't view it that way. They handle it differently. They don't consider capture from the tanks to be part of the process. And it's an important issue for the operators to understand. So stay tuned, because after the first year, our next webinar will be covering the regulatory treatment of tank vapor and vapor management. Emily, can you share with us the winner of the contest?
Yes, so I get to do the honors. Okay, so based on the configurations and the results we just walked through, I'd like to officially declare full capture from tanks using EcoVapor's technology, the superior technology and champion of the trial. As we just discussed, this configuration resulted in the lowest emissions and best economics. So really was the best solution for the operator in achieving this environmental goal of reducing tank vapor flaring. So let's move on to the next slide. Yeah, yay, I wish I had a bell. But as an add-on to that, the operator ran this trial for us, provided some great data on the economic benefits of the full capture solution over a 77-day measurement period back in 2018. But I'd like to spend a moment briefly summarizing the illustrative benefits of the solution on an annualized basis in the current environment. Here we took the same oil and captured gas production data that the operator provided, but conservatively assumed only 1% of the oil sales uplift was directly attributable to the EcoVapor configuration. We also declined those volumes off by 55% in the first year to simulate first-year production decline of a new well pad. So, applying current equipment cost, net commodity pricing, et cetera, really taking the analysis a few steps further by applying an illustrative royalty burden, midstream gathering and processing metrics, and production and ad valorem taxes, we truly got to the free cash flow to the operator under both configurations. Similarly to the results observed by the operator in the field trial, we calculate that the tank capture solution using EcoVapor's technology provides over 2.5 times the present value of the partial capture solution using the VRT, again over this illustrative 1-year period. And this is despite higher equipment costs associated, slightly higher equipment costs associated with the tank capture solution.
Yeah, and I'll harp on emissions again. I mean, normally when one thinks of reducing emissions with adding equipment, you think of a cost, of an increase in the costs. But in this case, it's an unusual value that operator has the opportunity to substantially improve their environmental performance and make a decent return at the same time. So it's a unique opportunity for many operators.
Yeah, definitely a win-win. So now I'd like to invite Mike to summarize what Jeff, Hans, and I had just discussed and wrap everything up. Great,
thank you, Emily. At EcoVapor, we're very excited about the impact that our solution brings to operators and also brings to our environment. The results shown in the webinar, as has been previously stated, are typical for most EcoVapor installations. So this slide summarizes the benefits and the value that our solution brings. So just to highlight a few, there's no moving parts. So, as Hans mentioned, the 02 typically shows well over 99% uptime and mechanical availability in the field. As previously shown, the emissions are dramatically reduced by capturing 100% of the tank vapor. In fact, a single E300 can prevent the generation of 20,000 tons per year of CO2 equivalent. As Emily mentioned, the economics in a typical installation are very compelling. So in a nutshell, as we've already said, operators can achieve their ESG and compliance goals with a very healthy payback. So at EcoVapor, we are the most economical solution for operators who are working to achieve an emissions goal or solve an environmental problem. Some of the less evident benefits one is the ability to manage tank pressure effectively. So by keeping the thief hatches closed tightly, the operator avoids the risk of fugitive emissions and also reduces our maintenance costs associated with thief hatches that are opening and closing. And with 100% vapor capture in a pad design, the site's potential to emit is minimized, which allows for more wells per pad and streamlines the permitting process. So beyond upstream traditional application, our solution also has application in central processing facilities. We have several installations, mainly in the Permian, at central processing facilities where they're working very well. In addition, our solution has application in midstream, at loading terminals, and also with renewable natural gas, with landfill gas and biogas. So we're very excited at EcoVapor about our solution and how we can work with a lot of different operators in a lot of different ways. So in summary, thank you for your interest in EcoVapor, and we would welcome the opportunity to discuss your application and your goals, and even offer a complimentary site assessment of one of your facilities to begin the discussion. We have really a great high energy team, and we're ready to work with you to achieve your goals. So thanks for your time and interest, and I'll hand it over to Jeff to close out and answer questions.
Yeah, I'm scribbling some of these down right now, Mike. Got a lot of good questions coming in.
Okay, great.
Let's start. One, Hans, you might want to handle this. So we've got a question about nitrogen. Can the 02 handle nitrogen? And I'm guessing the answer is going to be, or a question about the limit or the effect of nitrogen.
There's really no effect of nitrogen being an inert gas. It's essentially pass through. CO2 in high concentrations can hinder the reaction. Doesn't mean that it won't happen, but we just have to operate at a higher temperature to achieve that same efficiency. But in terms of nitrogen presence, that shouldn't help or hinder either way.
Now let me follow up. If there was a very, very high level of nitrogen, would we have enough C's and H's to do the reaction?
Yes, as long as hydrogens are present, or hydrocarbons are present. Yes. Even hydrogen would work.
Okay, I have another question, and I'll just answer it myself. Yes, we sell and lease the units depending on the customer's preference. Let's see, I've got a question here about, do we have data, Hans, from the trial on the effect on the RVP and the API gravity of the oil sold versus, well, under the two scenarios?
Yes, good question. So when we do add that two-phase liquid scrubber downstream of the VRU when operating directly off the tank battery, we are harvesting NGLs. They are the heavier side of the NGLs, but we are harvesting those and then sending those back to the tank battery itself. What we have measured, this was with a different client, is that we had an increase on the API gravity by increasing their sales volumes. I think in this instance, it was about 2%. We also increased the API gravity spec on their sold oil by 2 degrees of API gravity. In that particular instance, they didn't take a haircut until they were above 50 API. I think we ended up at 48, starting at 46. So really, in this instance, there was only benefit to having more produced volumes, but they did go through the analysis. And even if they did get into the 50s, where they started to see a haircut on product pricing, they still were money ahead by adding the volume to the tanks. That's a good question.
Mm-hmm. Okay, cost of replacing regenerating catalyst.
Good question. So again, not very often. The nice thing that EcoVapor tries to do for our clients is when we do have to regenerate it, again, the catalyst doesn't get used up in the reaction, but it can get kind of masked or coated with carbon, actually, that prevents gas from getting to those active catalyst sites. EcoVapor will come out, we'll pre-schedule it with the operator. We're using that remote monitoring system to determine performance. And when we start to see something creeping up to the pipeline specification, that's when we'll give the call to the operator, see if they have any planned site work coming up. If they do, we'll schedule it with them. And then we can remotely turn those units off the night before. Again, this has been coordinated with the operator beforehand. But by the time we arrive the next morning, units are cooled down. We open up the flange. We use an intrinsically safe vacuum to suck out the spent catalyst. And then instead of taking that same batch of catalyst and regenerating it, coming back a couple weeks later once it's ready, we bring a new batch of catalyst out with us so that as soon as we suck out that spent batch, we've got a new batch ready to go. Pour that in there. Y'all will be up and operating by noon. In terms of the cost, we're looking at roughly between 5 and 10 cents on the dollar for a regeneration process compared to what new precious metal catalyst would look like. But Emily, perhaps you could give a figure for what that might look like for maybe an E300 unit.
Sure. Well, and I'll just mention, one of the, as Jeff mentioned, we have, a very attractive lease option for our units. And so actually in the lease option, that is baked into the lease cost, assuming there's no contamination by the operator of the catalyst, again, putting liquids or H2S down the pipe. So that's actually all baked into the long-term lease rate. But in the event that the catalyst is damaged, we just have to see what can be done. And it'd be $5,000 to $10,000 depending on the situation. But really, that's one of the many benefits of the lease option.
Okay.
12 to 24 months.
Yes.
Okay, I have a question. A gentleman asked a question about the trial. Do you remember what time of the year these two 11-week periods occurred, and would seasonal conditions impact the results? Really, kind of getting at, is ambient temperature in the dead of winter, and I think this is in the Powder River, in the dead of winter versus summer, would it affect the results that we presented today, or the performance?
Those are more good questions. This trial was conducted, I believe, in late September, early October, kind of second half of September, first half of October. No, wait, it was longer than that. It was in quarter three, moving into early quarter four. That said, seasonality does affect volumes. Not only is flash essentially an effect of a pressure differential, that's not going to change from season to season. That's just a function of pressure drop upstream of the tanks. But you can get into a scenario where you're working, standing, breathing losses, as they're referred to off the tank batteries, are significantly reduced, especially in northern territories where it does get cold. But we still do see the effect of diurnal heating, where when the sun comes out, even if it's cold outside, those tanks do absorb that radiation energy, and you can see that. But I'd say in the macro trend, yeah, it's true to say that in the hot summer months, you'll see more vapors effectively coming out of the tanks themselves.
Okay. I've got a question about gas blanketing. I have a gentleman asked, it seems like a gas blanket does the same thing as a 02. Do we have comments on which one might be more effective, or which one do you be using?
Is it okay if I start out on that one?
Yeah. Sure.
So in 2010, EcoVapor started out with the solenoid-based gas blanketing system to try to prevent air from entering into the tanks, therefore keeping oxygen levels under control. Pretty quickly, we realized after the midstream company showed up that we weren't perfectly effective in that. And what we learned is that while it's kind of like VRT and 02 are, the Venn diagram certainly crosses into, under the umbrella of vapor capture, gas blankets can play in that as well. But it's a different, the original purpose for a gas blanket was to prevent an explosive mixture from forming inside the tank battery. It was essentially to say, okay, let's keep enough air out that we don't form a flammable or explosive mixture. And somewhere, I don't know, maybe a decade ago, gas blankets were looked at as potentially a way to keep out enough air to be able to sell all that vapor. And in certain instances, that's totally doable. A lot of times that comes down to how closely the gas gatherer is scrutinizing oxygen content. You know, if there's a continuous analyzer flam valve on that facility, I haven't really seen any tank vapor capture with just a gas blanket that's able to facilitate that at all times. That said, gas blankets can be quite effective in the right application. It's just a couple of orders of magnitude difference between where that flammable or explosive mixture would form and a typical gathering specification for oxygen that's usually 10 parts per million. So if it can work, it's usually a function of people not looking very closely at the oxygen content that is being delivered. And if there's not an issue with selling it, then there's not an issue with selling it. But in instances where that is scrutinized, the 02 actively controls that oxygen. And I think that's the difference.
Yeah, operators I've talked to, Hans, I mean, they can have mixed results. Sometimes they can chase down the molecules, and sometimes it's just, they just can't find the source of the oxygen.
Yep.
We get compliments from our operator customers that our systems, operate, very, very, very effectively and very reliably. And so, the management of gas blanketing system or other things could consume bandwidth with the operator, whereas we get compliments from our customers where they say, we put in the EcoVapor system and it just works and we don't have to worry about it anymore. So, that's certainly an advantage. Also, just our ability to manage tank pressure, very, very effectively and very reliably. Our system is just it's so reliable that you can permit around it, and you can count on those consistent results.
Interesting. I've got a comment here. It's actually not a question, but it actually is an operator who's indicated that he's assuming that if we control the tank pressures, we can keep the hatches closed. And they see that as a benefit, particularly in high H2S regions, where being able to have surety of keeping those hatches closed is a real benefit. So we owe you a gift card. Get a hold of Mike after the call. We'll get you one in the mail.
Absolutely. Thank you.
Another question. Do we provide VRUs along with the 02?
EcoVapor has consolidated our compression fleet into the DJ Basin. Outside of the DJ Basin and also inside the DJ Basin, EcoVapor works with third-party VRU providers as well as operators to find the best match. Sometimes an operator might want one throat to choke if there is an issue. In those instances, oftentimes EcoVapor does provide compression if it is within the DJ Basin. In other instances, they have existing relationships or other preferences, and we work well with those too.
We have great relationships with all the different VRU providers, and some of those dynamics or preferences are basin specific, but the 02 unit does need compression upstream of it. We don't have that compression within our product portfolio, but we do work with all VRU manufacturers and or providers, and we would be willing to put together a package for an operator if they wanted a one-stop shop. We've proposed in the past where we provide the VRU and the 02, and the SCADA system that Hans described earlier can monitor both components of VRU and the 02, and we can monitor those and even be responsible overall for maintenance of that.
Okay, we've got a question about installations in Texas in other applications such as landfills, food waste, or biogas. Do we have installations in other applications other than oil and gas, particularly in Texas?
We have provided proposals into landfill and biogas. The company historically has been very focused on upstream oil and gas, and so that's where we've gotten our traction to this point. But as we grow, we are branching out, and we're very active in conversations right now about a couple of biogas applications and a landfill application, and we're perceived as a very good fit.
Yeah, I might also add that we are, it's still upstream oil and gas, but we are actually working now in the saltwater disposal area and providing solutions to keep the risks of the damage from lightning strikes to remove that vapor from saltwater disposal sites. James, do we have time for one more question?
We do, Jeff.
Okay. Okay.
I know there's a bunch, and we might have some follow-up, but yeah, one more.
Okay, let me make sure. What's generated in I'm going to have two questions, James. One, what are the catalytic reaction products?
Water and carbon dioxide, and you create less. How are they handled? Okay, so less water and less carbon dioxide is produced than the original concentration of oxygen at the inlet feed. So depending on specifically which hydrocarbon is reacting, that can change the specific ratio of carbon dioxide and water that is produced, but it is always less than the amount of O2 that comes in. And they're handled very simply. They're just entrained in the stream. It continues out the outlet. 02s have one inlet and one outlet. What goes in comes out. There's not some side stream that's removing oxygen or any of that carbon dioxide or water that is produced. That said, we know that there is gathering specifications. They can vary, but there always are specifications for water and CO2 concentrations. EcoVapor in our almost 11 years of operation have never, ever once come up against that. And the reason is that whereas oxygen typically has a 10 parts per million contract, CO2 is typically tariffed in the percent range, sometimes 3%. And then water also measured in the pounds per MMBTU. We haven't busted that specification either. In certain areas where we do need to meet even more stringent specs, there are ways for us to handle that. We've worked with some operators before to do so.
The last question, the diagram shows the scrubber. You mentioned the scrubber before the 02. Is there other equipment that's typically used or required for an installation?
No. And the scrubber is really there to harvest any of those NGLs. On a richer stream where liquids are going to be present, it is a good idea to put that in. But on, say, a lighter stream like a biogas stream, not even the scrubber would be necessary. These are perfectly standalone units. They don't require any external inputs or handshakes with other equipment. You can set it and hook up the power and you're done.
Thank you. Thank you, panel. James?
All right. Well, thank you. Thanks for that. Thanks for the handoff, Jeff. Everyone from EcoVapor, thank you, panelists. This was a great discussion, and I think based on the amount of questions which we still have rolling in, unfortunately, we don't have time to get to all of them. But Jeff, I'll make sure that you get them and you can respond to the people individually. So thank you very much. This concludes the Tank versus Tower webinar. We hope you have a great rest of your day.
Thank you all.
Thank you.
Thank you.